Hello everyone, this is Shreya from Test Automation Competency, and my topic for NashKnolx is Compose Preview Screenshot Testing Plugin, which prevents regression. So we should be punctual for this NashKnolx session. We should join 5 minutes prior to the start time. Feedback is a must. Silent mode, keep your mobile phones in silent mode, and feel free to move out of the session in case you need to attend any urgent call. Avoid unwanted chit chats during the session. This is the agenda for my session, which is the introduction to the screenshot testing. I'll be explaining what is regression testing, what is Compose Preview, what is Compose Preview Screenshot Testing plugin, why do we use it, Google Screenshot Testing Framework, like this is the plugin which we are using it here, and how it prevents regression, the demo, then will be the Q&A session, and the reference is also being provided. Now we start like introduction to the screenshot testing and Compose Preview. So at first, what is screenshot testing? It basically involves automatically capturing and comparing screenshots or the images. Like if we take the one image as a baseline image or the reference image, and then a screenshot is being taken and that is compared to the actual base image to detect any changes, the visual changes. So screenshot testing is a way to ensure that the design and the layout of our application is the same, like is the same everywhere, and it looks right as we like continue developing our application or like using the application. We basically use this method to automatically take pictures of the parts of the application or the whole application. For an example, we can take screenshots of particular components like buttons, menus to compare their earlier versions, which is basically in the reference image. Then we compare it with the screenshot. So like imagine like we are working on an application, and every time we make some changes, like we can think of it like if we are like some people are working together in a project. So if one developer is making certain changes, the other is also doing his part of the job. Like he's also working on the same part, and both are doing the changes, but the other person doesn't have to like do the change for the specific part, but unintentionally there is some changes made to the application, which is not like which is very minute, but like it is not seen from a normal eye. So that can be captured through screenshot testing. For example, in these two images we can see, if we see through our normal eyes, these both will be like the same. They are looking like the same image. Nobody can spot the difference. But when we come to the next slide, here where the screenshot is being compared, we can check like the color and elevation. Both are different. So this cannot be spotted from like this cannot be spotted manually or from our normal eyes, which is captured by the screenshot testing. Like here the elevation is 4 density independent pixels, and here it is 8 density independent pixels. So the next we'll be seeing why we use screenshot testing, why there is the need of screenshot testing. As I explained earlier, that there are some visual changes which cannot be seen very like which are very minute and are not like we cannot identify them through our through us, which doesn't even affect the UI also. So to test and to check that, we use screenshot testing. So here the first is it catches the UI bugs, the subtle UI bugs very early. With the screenshot testing, we can basically like we can quickly spot the small mistakes in the user interface that might which might be hard for us to notice manually, but they are there. The bugs are there, but we are unable to find them. So the examples of this can be like for a button maybe shifted a bit, like a pixel only, but it has been shifted. So that can be that can be caught through the screenshot testing. Then the next is visual testing. As we can see here, we like in the changes of UI elements, whether the UI elements have been shifted, changed, or whatever modifications have been made here. The navigation and layout, like navigation bar has been changed, the color theme has been changed, or the style, shape, size, fonts, whatever has been changed visually can be like caught from this screenshot testing. It is like easier and it saves time also when we perform the screenshot testing. So the next point is the component level testing. The component level testing, this screenshot, like this part basically focuses on the specific elements or the specific parts of the application, such as like uh, for example, just a form or just a specific part or just a module. And for that we do not need to test we do not need to test the entire application every time we are testing. For that we can just, like, if we are making changes to a specific component or a specific module, we can check and test it uh, like on this component level. So there is, like, it saves time also, it saves memory, where we do not need to execute the entire application every time, making us like easier to pinpoint the issues where things might have like gone wrong. And the next is the like platform consistency. Here we can see we are using different browsers, we can use different devices. So with different browsers and devices, they are like changes are certain to be appeared. Like for an example, the resolution or the font size, something can be changed, which are not intentional, but can happen like while shifting to another platform. So that can also be caught with testing. It ensures that the design looks same everywhere. It helps us maintain like the same UI, or the like it maintains the consistency across all platforms, so that user can have a smooth and seamless experience no matter which device we are using. Now the question arises that why we started using screenshot testing. So the first point is like growing complexity in UI development. As we can see there, nowadays it is very like the apps and the websites have become more advanced, and the designs and layouts are more complicated than before. Um, as we know that we nowadays use more of animations, different themes, and uh, like many tiny detailed elements are now being used. For an example, we use GIFs, videos, shots, so that are like we cannot catch them through or like normally or manually, like the color changed in the video, or these changes can be occurred. So that we we started using screenshot testing to compare the reference image and the screenshot, or like the image is same or the content is same, it doesn't get changed, the position of the element is the same. So for that, we started using this. For agile and CI/CD pipelines, it is basically a solution where it automatically verifies the visual integrity without our intervention, which is, for an example, like nowadays we are bound to use CI/CD pipelines where we are continuously updating our apps, adding new features, and finding bugs, fixing them. So in this environment, we do not have that much time that we check like every time manually. We check every single module or screen of our application. So there we can use screenshot testing. It helps us to do this automatically without checking, and also it checks to see if anything doesn't look wrong. For example, if we can think of it like we are working on any app of social media where updates are being released like in every 7 days, or in every 7 days, or like alternative month updates are being released. So it is very helpful to catch them, like we cannot manually see every time that whenever the update is being released that any changes does appear in any module or any screen of the entire application. So here we can use screenshot testing. For it is also helpful in cross platform ecosystems, as it supports multiple devices where different forms of screens are available, different sizes are there, and resolutions. So there also, uh, for an example, we do work on our mobile phones also. We use tablets, laptops. So for that, there are different operating systems. In this screenshot also helps to check whether the pixels of the entire application or the part of the application is exactly the same in every platform we are using. Now, understanding regression. Basically, what is regression testing? As we know, any unintended change, like regression testing, is basically a type of testing that we perform to ensure new changes in the software do not uh, fails the existing features. Like working on a module, for an example, we take an example of the WhatsApp. If we have updated the privacy section, it shouldn't interfere in the chat section uh, or the calling feature. So like every module should work independently and fine without having any negative impacts on the existing functionality. For this, whenever we make updates or add new features, we want to make sure that everything still works as it should be working. Now, when do we use it? Basically, we use regression testing after we fix any bug, or we do the code refactoring, or we are adding new features. Like anything we had changed in the software, we need to perform the regression testing to check whether the functionality remains the same, or it has been affected by the changes or the modifications. So the outcome is that it confirms the system behaves as expected and no new bugs are introduced. Key benefits of the regression testing. So validating fixes for reported bugs, ensure that the fix doesn't introduce new changes. Uh, And for before this, I would like to tell more about regression. That how do we perform it? It is simple. It is the simple testing where we first identify the cases, then we, if required, we automate them. We perform the test to check if everything works as it should, and then after running the test, we analyze the test results to identify if there are any failures or we need to fix anything or any other bug appears. So if any changes, like if there is any failure, then the test has to be performed. Like it should be fixed. First the changes has to be fixed, and then we need to perform the testing again. So that, and we do this every time until the changes, until the functionality is the same. So we have to repeat. So basically, regression improves the quality. It validated, like it helps in validating fixes. It helps in detecting the unintended changes. It helps preserving the UI experience, ensures the code stability, supports CI/CD. It also improves the quality of the code as we regularly check the software that it is reliable or not. It also builds the confidence. It saves time for us. So for the first point, validating fixes for reported bugs. When we find a bug in the software, we try to fix it, and we want to make sure that our fix really works. Regression testing basically helps us do that. We can we can test to check if the bug is gone and if everything else is still functioning correctly. For example, we we think of a bug that had caused the we think of an e-commerce website where an add to cart button stops working. So after fixing that issue, we perform the regression testing to ensure that the uh, button after fixed works as expected, and the and like it we can smoothly uh, we can smoothly come to the checkout process. This way we can confirm that our fix doesn't create any new problems. So the second point is detecting regression early. Sometimes changes in the code, like the changes which we perform, are unintentional. So by performing regression, we regularly check and catch these issues early before they reach the users or the production. The sooner we find the problem, the sooner it is to fix. So this is very important, detecting the regressions as soon as possible. Preserving UI experience, a smooth UI user experience is crucial for us to be happy, for our users to keep happy. Uh, like, this ensures that new features don't disrupt existing functionalities. So we provide a consistent experience for all of our users to ensure that we like we perform regression testing. Now the code stability, as we add new features or make some changes, it is important to make the application or the software stable. Basically, regression testing allows to confirm that the code remains the same exact functional. This way, we building trust with our users is essential to is essential by maintaining the stability. For an example, like we are logging in, adding items to the cart, and checking out without any issues. So like the stability is being maintained after we performed the performance and the regression testing. Regression testing also supports CI/CD, which means that we like it is nowadays a practice to make changes and deploy the updates quickly. Regression testing is just a part of that process. Uh, it allows us to automate tests and ensure that the changes doesn't break anything like before we release them. With CI/CD, every time we make a change, regression can be automatically executed, or like we can run CI/CD automatically to check for any issues, which can quickly release updates while like everything still works smoothly for the users. So regression testing brings many benefits to our software development process. It helps us validating bugs, detects issues early, our UI experience is maintained, our codes is stable for every cross browser or cross platform. It supports the like supports efficient deployment practices also. Now the main topic, which is compose preview. So basically, compose preview is a feature in Jetpack Compose that allows developers to see the real-time previews. That is the real images without like having the run like without executing the whole application on a physical device or an emulator. We can provide instant feedbacks that how the UI is looking or behaving. So understanding compose preview for understanding compose preview, we can break it into like the terms compose and preview. Compose is basically refers to the toolkit, which is called the Jetpack Compose, which is a part of Android. Uh, the toolkit allows us to create user interfaces in a more like straightforward and efficient way. And preview is basically like refers to the features that let us see how a UI will look without having run the entire application on the device or an emulator. So these when these two are combined, we can see the developed application while uh, while developing it side by side. We can develop the application and see its real-time changes. What changes we are making and how does it look. We can see it like side by side. So this like helps in making the design process faster and more efficient. Now, what challenges in Compose preview screenshot testing? So here, first is dynamic data content. If we talk about dynamic data content handling, screenshots may vary because of the dynamic data. For an example, like this can include things like live data for the scores in a sports app, or like the weather application, weather can be changed, or the timestamps, the current time can be changed. So like to like this is the major problem, and with this framework we can use customizable comparison thresholds, which is basically we set some thresholds to uh, we set some thresholds to ignore the minor differences and just focus on the specific UI areas which we want to make sure that doesn't change. We can do it with this framework. Cross device consistency. This is basically uh, it means like making sure that our application looks and works the same way on the different devices, whether it's smartphone or the laptop or a tablet, this can be challenging because every device has like different screen size resolutions, which can affect our user like our interface. So the solution for it with Google Framework is multiple device. It supports multiple device testing to ensure consistent UI behaves exactly the same across various configurations. As we take screenshots, which can be compared with the base screenshot, which so after comparison we can get to know which changes have been occurred. Next point is time consuming setup and execution. Setting up and maintaining traditional screenshot testing tools can be tedious. Like maintaining a traditional screenshot testing can be very lengthy process, as we need to like set marks and we need to explain everything about it, like where do we need, like when to take screenshots, everything has to be explained. But with this Google framework, as it is directly like integrated with Jetpack Compose, which is specifically designed for Android, this uh, like in this we just need to add some libraries and plugins, and after that it is get to go. Like we can simply set up this by adding some libraries and plugins, and uh, like we can use it. So it is very like less time consuming, and it also improves the execution speed. Baseline image management. Managing a large number of baseline images across different devices and configuration is very difficult. As we all know, having different baseline images for different devices and configurations, that is a lot to handle. So in this Google's framework, it offers flexible baselines for multiple devices and configurations. It simplifies the management as it just creates folders for different modules and different devices, different configurations. So it is easy to handle this with this framework. False positives due to minor UI changes. Like if small changes also made, we are, as in the first slide we have seen that we are unable to find those changes, which can trigger the test failures. Like if done manually, it can be ignored, but when done through this, it can trigger the test failures. So with this framework, we can set tolerance levels. It can allow minor pixels differences, that live data one, like we can set some thresholds through which it can allow the tolerance level and allow minor changes or minor pixel differences, which just focuses on the important parts and the significant parts. Next is the continuous integration. Like difficulty in integrating visual testing into CI/CD pipelines for regular checkups. As we all know, doing it manually or like integrating it with any other visual testing application is very difficult to handle, because most of them are mostly paid, or like we have to buy them, or if they are like very difficult to integrate with, because we had to write a lot of code for them. But for this, this framework is very optimized for CI/CD pipelines, as like just adding some libraries, and it can be easily integrated. Also allowing automated and regular visual regression testing. Now, what is Compose Preview Screenshot Testing plugin? As we know, what is Compose Preview Screenshot Testing? To handle that testing method, we use plugins or tools. So a plugin which integrates with this Jetpack Compose Preview, which is used for Android. So we integrate this Compose to the Android, which can automatically capture the screenshots during the UI previews and then compare them with the baseline, helping us to prevent like the visual regressions or the minute changes or the unintended changes. Main purpose of that is to like main purpose of the screenshot testing plugin is basically to ensure that our apps like that our application's user interface remains consistent and visually appealing every time. So by comparing screenshots, we can easily and quickly spot any unintended changes or issues caused by any updates or like while the new feature has been added. So we can easily fix that with this tool. So it is very helpful. It basically catches the UI bugs early, very early. So why do we use compose preview screenshot testing? Like what is the need for compose preview screenshot testing? It ensures the visual consistency. As we can see here, when we switched browser from, for an example, we were working on Mozilla Firefox and we switched to Chrome. So there it has been changed to the night mode, from the light mode to night mode. This can be avoided through this can be detected and avoided through this compose preview screenshot testing. Like it ensures the visual consistency among all the browsers. Like it should be consistent and should remain the same for every browser or platform. So it prevents unexpected changes for the code modifications. It is also helpful to detect early visual regressions, that is like checking the changes, as I have given the example of like the developers working on the same repository. They are intended to there are some changes made from both the ends which are not intentional but are added to this, so that can also be like tracked with this. It saves a lot of time and it as it removes the need for manual visual checkups. Like the screenshots can be compared with the baseline or like streaming the testing process. Why do we use like why are we using specifically Google's screenshot testing as there are also some other frameworks available? We are like we had to work on like if we are working on Android, this is the best as it is the official tool from like Google and it is free of cost. We can use it like anytime and it is very simple and easy to use as I have explained earlier that we just need to add some libraries and plugins to our code and we are good to go. So in this, why do we use it? Compose specific focus. We like built specifically for Jetpack Compose for Androids, which is native support for testing Compose UI components. Like for some specific components, also we can use this. Advanced image comparison. It utilizes robust algorithms to compare screenshots. It basically gives us pixel perfect images, no with high accuracy, and like ensuring everything remains the same. Baseline flexibility allows us to set up flexible baselines for different screen sizes, configurations, and themes. For an example, the color has been changed, the theme has been changed, or any element has been shifted a bit, a pixel also, then also it can, like, it is able to catch that. And the test execution is also very efficient, very optimized. We like it is very quickly done, minimizing the delays during the development and improving the speed of the regression testing. It is very helpful for large projects as we do not have that much time to look into every screen every time. So like it is easy to check it with this.
Shreya, I'm sorry to interrupt in between, but we just have 5 minutes left for the session.
Yeah. So, like the key benefits of this Google screenshot testing, it is consistent for all across every device, whatever device we use, it should remain the same. We can set thresholds and we can also customize the comparison, like comparison points. So we can do that with this. It is like it provides faster feedback. We do something, we measure, we analyze, correct, and then repeat this process. It can be easily integrated with CI/CD pipelines. The mechanism for the framework, as we can see here, this is the reference image. The screenshot which we took is this. So here it compares both the pixels and it can give the reference image, or it will fail the test. And if the test matches, then we get a test succeeded result. Now, how do we prevent regression? It ensures that no unwanted visual changes has been introduced. It helps maintain pixel perfect designs across apps versions. It minimizes the manual UI testing efforts. It provides instant feedback on visual regressions, allowing teams to fix issues before they have become more complex or reach the production. We had to catch them early as soon as possible. Therefore, it helps in that. Now for the demo, I'll be showing you this. Uh, Here we just need to like add the version. This is screenshot version here in the version file. Then we need to set the properties. We had set this flag true. Android experimental enabled screenshot test as true. We just like need to set this flag, like we just need to mention this flag here and set it to true. We need to add the plugin for the screenshot testing here in under the plugin section, and in the dependencies we need to add just a dependency here, screenshot test implementation. And then we just need to like create a folder under apps section, this preview folder. This we can see the Kotlin folder, and here we will create a file preview.kt. In this we just need to, this is basically my code for the application. I need to run my application. So this I have like written. This is the composable and this is the preview part. In this preview part, we just need to copy this preview part and we need to paste it here. It will automatically take the imports. And also it is necessary to like update the versions. Then like then we just need to give the, yeah, then we just need to give this we need to run this command, which is update debug screenshot test. See, this is the application which I have developed. So this is the application which I have developed already, and then we need to perform this. We need to perform this action here. It will update the debug screenshot test under this build folder, Kotlin. Oh, sorry, under this app src debug. Then in debug we can see here the screenshot, like it is extracting the this UI.
Shreya, we just have last 30 seconds left for the session. Can we please
Yeah.
close this?
So now the build is success. We can see we got the reference image, base image. Now if we execute the this command, which is validating this, then we'll get like a folder will be created here as test results. See, the test results folder has been created, and here we can like check the test one test has been executed, no skipped test, failures none, timestamp also has been recorded here, and it is success. We can see in here in the terminal also, as well as in the XML file also. So this can be done very easily. Any questions for this? Also, I have provided the reference if you want to check the whole demo. How do we perform this? This is the video link, and this is the step by step, like every plugin versions, everything you will get in this link.
Thanks, Shreya, for the wonderful session. Yeah. So, guys, if you have any questions, please feel free to reach out to Shreya, and she'll be there to answer your questions. And thank you, Shreya, for the wonderful session. Thanks everyone for attending the same. See you all soon in the next session, guys.